dugsiga boardingka iyo maalinlaha ah ee Amano boarding and day.
Assalamu alaikum warahmatullahi wabarakatuh. Welcome from 3s. This is first lesson of video lessons, and it will be lesson 3 from analytic geometry. We did for analytic geometry from our normal lessons. We did how to find the equations of a circle with center at the origin and with center as h and k. Also, we did how to find the equations of a parabola which has a center at which has a vertex at 0, 0. Today we will start how to find the equations of a parabola with center, or if we translate the center to h and k, or it is different from the origin. It is different from the origin. Okay. This is a parabola with a vertices not at the origin. It means that we are considering the vertex of the parabola. It should be h and k. Okay, we have 4 formulas as we did previously. The parabola can concave up, or it can concave down. It can concave left, or it can open to the right. Parabola, the definition of parabola was the set of points that are equidistant from a given point, from a fixed point, called the vertex, the focus, and a line which is called the directrix. Therefore, we are told that the distance from the vertex to the focus is the same as the distance from the vertex to the directrix. Also, let me tell you one new information. A line that passes through the focus and perpendicular to the axis of symmetry, it is called the latus rectum. It is called latus rectum, and it is 2 times p. It is the length of that line goes to 4p. It is 4p. Therefore, we have 4 formulas. Y equals 4b x square. X equals. These are our previous formulas. Okay, the equation of a parabola where the vertex is at the center can be y squared equals 4px plus or minus 4px. It means that whenever y is squared, the parabola will concave either right side or left side. When p is negative, it concaves left side. If b is positive, it concaves to the right side. Also, we said that x squared equals plus or minus 4py. As long as y is squared, then this parabola, it concaves up or down. It depends on the sign of p. If b is negative, it concaves down. If it is positive, it concaves up. Therefore, today's lesson we will translate. We will do some translations at the vertex. Look, if the vertex of a parabola is at a point of h and k, is a point of h and k. H and k. Look, the previous parabola, the vertex was the center, but if we translate, look, it moves. The center goes to h and k. H and k. K is from y and h is from here. Look, this is the vertex, and it concaves up. That is the axis of symmetry. Therefore, the focus is on the axis of symmetry. And the directrix is the opposite side of the focus. It goes here. It is horizontal. Therefore, how can we find the equation of this parabola? We will simply use this one. The original equation, which was y squared equals 4bx. At this case, it comes to y minus h squared and equals 4b into x minus h. Also, y equals minus 4px, it goes to simply, we will substitute the place of y into y minus k and the place of x into x minus h. That this one, it has a power of 2 and it is y. It concaves to the right or left side. For x squared equals 4py, we can use this one if the vertex is at h and k. when the vertex is h and k, we have 4 different formulas. That means that we have 2 vertical parabolas and 2 horizontal parabolas. We will continue how to find the equation of a parabola. Okay, also we have here for some standard equations of a parabola. Look, this is standard equation is of a parabola. This is the axis of symmetry. How we can use we can form the equation. The focus, the directrix, and the end points of the latus rectum. Latus rectum is the line that passes through the focus and perpendicular to the axis of symmetry. The axis of symmetry. Therefore, if the axis of symmetry is horizontal line, it means that y equals k. This is the standard equation of a parabola which is facing to the right side because p is positive. And the vertex is h and k. Therefore, the focus, look, this is the vertex. It is h and k somewhere here, h and k. And we have the axis of symmetry as y equals k. Y equals k. Therefore, in order to sketch, let us draw the focus. The focus is b unit is right from the vertex. Therefore, it goes here as f is h plus b, comma k. Therefore, our parabola concave is to the right side. To the right side. It opens to that side. Therefore, if the focus has h plus b, then the equation of the directrix goes h minus b. The latus rectum is that h plus b, k plus or minus b. Simply we will add k plus or minus 2b. One time you will add 2b, the other time you will subtract from 2b. This helps us to draw a very neat diagram. If you want to draw a very neat diagram of a parabola, it is better to use the latus rectum, the end points of the latus rectum. Then you can join easily. Therefore, these are the standard formulas of a parabola with vertex h and k. Also here we have the graphs of the parabola where the center is h and k. Look, this is a parabola. Here we have horizontal parabolas where the center is, where the vertex is h and k. Look here. This is the y-axis and this is our x-axis. This is the axis of symmetry. That is the axis of symmetry. As long as the axis of symmetry is horizontal, it means that y equals a constant. Y equals a constant number. And here we have the vertex as h and k. Therefore, the focus, if the vertex is h and k, the focus is p units and b units to the right of v. Therefore, this is our vertex h plus b and k, and this is the line of directrix. That's the directrix. Therefore, for this one, if b is greater than 0, it concaves to the right side. If b is less than 0, it concaves to the left side. Here we have the vertical parabolas. This one, it concaves up because we have, okay. For this parabola, it concaves up, and the vertex is not the origin. It is different from the origin. It has h and k. It has vertical axis of symmetry. If the axis of symmetry is vertical, then the equation is x equals a number. X equals a number. If the value of b is positive, it concaves up. If the value of p is negative number, it concaves down. Therefore, we have 4 different formulas for the translated parabolas. We have these formulas. Y minus k square equals plus or minus 4b into x minus h. This is the equation of a parabola which is facing right side or left side. As long as y is squared, then the axis of symmetry, it will be horizontal. The axis of symmetry, it will be horizontal. And the other equation is x minus h squared. It is plus or minus 4b into x, 4b into y minus k. This is a parabola which is facing up or down. It depends on the sign of b. Okay, let us do some examples. Let us do some examples. Okay, here we have how to graph a parabola with vertex h and k and axis of symmetry parallel to the x-axis. If it is parallel to the x-axis, it means that it is a vertical axis of symmetry. Here we have the equation of a parabola. It is y minus 1 power 2. It is minus 16 x plus 3. First, let us identify the vertex. We will draw later. We'll graph. But first, how we will state how to identify or label the vertex, the axis of symmetry, focus, and the directrix. We have these two equations. First, let us compare it to the standard equation of a parabola, which is y minus k squared equals 4p x minus h. What are the coordinates of the vertex? K is 1. Sorry, first we'll write h. H is minus 3. Because the standard equation is minus, therefore here if we have positive, it means that this 3 was negative. Therefore the vertex coordinates are minus 3, k, it is 1. That is the vertex. It's minus 3, 1. It's minus 3, 1. Therefore, to find the coordinates of a vertex, simply we will compare the given equation to our previous standard equations from the previous table. That is the vertex. Okay, what else? Let us find the value of p. Let us find the value of p. Let us find the value of b. Let us find the value of p. Okay, to find the value of p, we have here 4p equals, let us compare to 16. It is minus 16. Therefore, the value of p, it is 16 divided by 4, which is minus 4. As long as b is minus 4 and y is power 2, the graph of this parabola, it opens to the left side. Therefore, we can find the coordinates of the focus as h minus b, k. H minus b, k. Okay, it was h plus b, k. What was the value of h from here? It's minus 3. Plus, what is our value from here? It's minus 4. K is 1. Therefore, the coordinates of the focus are minus 7, 1. Minus 7, 1. Those are the coordinates of the focus. Simply, we have h and p. We will add them. Therefore, to find the equation of the directrix, instead it has the opposite sign here. If the focus has just h plus b, the equation of the directrix, it will be h minus b. Therefore, the directrix has this equation. Directrix, it has equation as x equals h minus b. The value of h was minus 3. Sorry, it was minus 3. The value of h, it was minus 3. And the value of p, it's minus 4. That's minus, which goes to positive. Minus 3 plus 4, therefore the equation of the directrix, it is x equals and 1. Here we have the vertex, focus, vertex, and the directrix. Then we will see how to draw the parabola. Look here, these are the information. This is the solution to this parabola. First, we should find the vertex. Look the steps. What is the vertex? What are the coordinates of the vertex? What are the coordinates of the vertex first? Sorry. This is the vertex, which as we did it, -3 and 1. The axis of symmetry, it is parallel to it is horizontal, it's horizontal, and the value is y equals k. Also, it's known that b is less than 0, it opens to the left. And the value of b is -3 as we did it earlier, and -4 as we did it earlier. The coordinates of the focus is h plus b, k, which is -7 and 1 as we did it. The equation of the directrix, if the focus has h plus b, the directrix is h minus b. That's -3 minus -4, which is 1. This is the equation of the directrix. For the latus rectum, we will use this formula as you did it earlier, or we don't need at this level, then we will do it later. Therefore, to plot this one, or let us do it here. Let us do it. The latus rectum is this. But it is the end point. It's a line that is perpendicular to the axis of symmetry and passes through the focus. Therefore, to find the end points of this latus rectum, we will use this formula, h plus b, k plus or minus 2b. If we substitute the value of h and b, k and b, we have this one, -7 and 7 as here, 7 and -9 as here. Therefore, we have 3 points on the parabola. That point, this point, this point. If we join these 3 points, we have very neat diagram. Therefore, this is necessary for drawing a very neat diagram. Therefore, today it's introduction to the parabola, which has a vertex as h and k. Then we will continue, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.